Okay, so first things first. Let's talk about today. So after we plug in distance and displacement last time, we are moving on to, once again, variable breakdowns. All of a sudden, I'm just calling it describing variables. I was just breaking down what variables are what, and this is 09, 18, 24. So let's talk about how we do this. So distance is going to just be one unit by itself. So think inches, think feet, think inches or feet. Time is a unit of minutes, hours, and that makes sense as well. Let's talk about velocity and acceleration. That's where most of us get messed up. So velocity is going to be something like meters per second, and then acceleration is going to be meters per second, then divided by, once again, per second means just divided by, because how many meters are going per second, but then it's going to be 2 units of time on bottom, or it's going to be squared. So if you see a square, we know it has to be acceleration. If we see meters per second, we know it has to be velocity because it's a distance divided by a time. Think speed is equal to distance over time. Velocity will be a distance and then a time. So for our first one, we know it's velocity. For miles per hour, that is miles divided by hours. That's also going to be a velocity. I'm going to skip around. If we see 2 units of time, we don't even have to think about it, just 2 units of months and hours, so inches divided by months and hours. We know it has to be an acceleration of some kind. If it's divided by just 1, like yards per minute, we know that it's going to be back to velocity. If it's just feet by itself, what is feet by itself? You know, it's a distance. And then, once again, seconds, we know is time, draw a T. Minutes, we know is time, draw a T. So practice these, come check it against mine, and feel free to use Google to be like, okay, what would this be? Once again, displacement is going to be, displacement or distance is going to be D or X. So just know that you can use D or X to refer to position or displacement. Whoops, that's a whole mess. Whoop, I'll do it this way. X. So if you ever see that, that's all it means. You can use D or X to represent our displacement or our distance. Walk through, practice these, pause, and then I'm going to go ahead and talk about the next thing. So, next thing we have is just our graphs and just graphing motion. On the side up here, here's what I'm going to do. I'm going to go ahead and write the title right up here. Whoops. And this is just graphing motion. And then same date. I'm gonna grab. Sorry, someone's at the door. There we go. So let's do this. So when we talk about graphing motion and showing motion on a graph, here's what this kind of looks like. If our velocity was at 0, it would be a constant position. Our position would not change. So remember that x can also equal position, or x can mean position. Let's talk about our axis real quick. So right above this, here's what we need to make sure we do write down. So this is going to be x-axis and our y-axis. So there's displacement versus time graphs, velocity versus time, and acceleration versus time. These are all for the same thing. If velocity is 0, there's no velocity, it would just be 0 the whole time, acceleration would be 0 the whole time, because acceleration, it is the change in, once again, change in velocity over time. So when we talk about our x and y axis for both of these, and sometimes it may be confusing because x we use for displacement, because once again, they're thinking position, like your x value, super silly, but it's something. Our x-axis, so the horizontal axis, is basically always going to be time. See little t, little t? So on position versus time, or displacement versus time, is going to be time, t. Velocity, same thing. And then acceleration, same exact thing. Now here's where we're going to change some stuff up. Our first one on here, our y-axis component, that is when we use distance or displacement. I'm going to write displacement on here, because usually we will see displacement used if we have multiple graphs like this. And that can be x, d, and some places even will use p for position. We try to avoid that because that can be confusing. You could think probability or some other p word. And we also use that for momentum anyway. Let's talk about our next one. Once again, just our velocity, and our velocity is our y-axis. So it's once again our up and down. This is our y-axis. And that's going to be v. And last thing, I'm going to have to reuse the color. Oh, ow, it'll be okay. So for our wax in this one, it's just acceleration, which is a. So our y-axis, once again, is up and down components. If you walk through these, you can see, once again, our motion, it's going, just add a constant, like, velocity away from this one spot, which we consider 0. Our velocity is constant, but that means we have no acceleration, because acceleration is our change in velocity. Same situation, we have a constant acceleration going up, it's constantly speeding up. Let's say that you're throwing on the gas pedal, slamming on it. Your velocity is going to constantly go up, and your acceleration is remaining constant until you let off the gas pedal and you start decelerating. Then, if we're constantly decelerating, let's say you throw on the brakes, we will get this kind of curve. Our position will slow down and we'll like skid to a halt kind of thing. Our velocity, once again, will go towards 0. It'll be a negative velocity. And our acceleration, it's a negative acceleration because we're decelerating. And that's basically all for the actual notebook stuff. Pause to make sure you are caught up on this stuff. And then let's talk about just our last sheet. We're going to just practice this. That's a hot mess. So once again, with this one, there's a few different types of questions, over position versus time graphs. Once again, all you're doing here is you're just drawing the graph. So slowly moving away from 0 meters. These are all position versus time. Slowly or moving away from 0 meters. And you're done. If it's stopped, it'll be a flat line like this. If it's moving towards 0 meters, that's down here. Think once again, our x-axis is time. And our y-axis is position. If it's moving towards 0 meters, this is 0 for d, or our displacement, or position. So we're starting like away from 0 and moving towards it. So the steepness is going to indicate how fast the object is moving. So if it's moving slowly, our steepness is going to be very slack, just like this. What do you think it's going to be if it's moving? And then, what do you think it's going to be with those two? Try those on your own. We have a key that for y'all to check this after we finish. Then, let's talk about how, let's see. Let's talk about how it changes. So if we're moving slowly, then quickly away from 0 meters. So first, we're going to start off by moving very slowly away from 0. So you're going to have a very low steepness line. Then you're going to have a very high steepness line following that line. It doesn't say when the change happens, so it can happen anywhere on this line as long as we see and we're getting what we're supposed to. And there's our displacement, and our time. Try these out and check it against the key. Let's look at these real quick. On position versus time graphs, when time increases, what's happening to the distance? Is it getting greater or is it getting less? Describe what the motion looks like, and the velocity is going to be the slope. Just like we saw in math class. And once again, if you want help working through that, I'll gladly help you. Walk up, ask questions, don't die. Not slope. On the back, make sure you see that there's a back. We're also going to draw a couple position versus time graphs. Let's talk about how. So the velocity of the car for the first 3 seconds. Once again, we're going to look at this. It's traveling 6 meters in 3 seconds. So it's going from 0 to 6 meters in 3 seconds. So there's our first dot. You might want to use a ruler. I'm going to just go straight for it and make it happen. On the next one, it's going to stop for 5 seconds. So it's just going to stay here for 5 seconds. So 3 all the way to 8. It's just going to be stopped. And then it's going to go 2 meters in 2 seconds. So it's going to go in 2 seconds. It's going to go 2 meters. And once again, I'm doing this fast because I'm just used to it. It may take you a little bit longer, and that's okay. And this is what position versus time graphs are. Now it's just finding velocity of each time interval. First 3 seconds. Our slope is 6 divided by 3. 6 divided by 3, because our slope is our rise over run. It is 6 divided by 3. 2. Velocity from 3 to 8. 3 to 8. Our velocity, because we're stopped, is, and then during which time interval are these moving faster? On this one, we can see that it's also going 2 over 2. Let's talk about our slope there. We can do this without calculating by comparing the steepness, but we can also just calculate the slope of this area. We're going 2 meters, 2 seconds. Rise and run. Which one's greater? And we got it. Practice these, check it against the key. No crying, no dying. We got this.